Hi! Many of you have expressed concern about the practice problems in Lesson 4 where you have to learn how to use vectors. So I have compiled 3 different practice problems where I've worked them for you so you could see exactly how they're done. I hope this helps you. Let's begin by looking at the first practice problem for Lesson 4. And this one states that a roller coaster moves 85 meters horizontally. Now I'm going to always draw pictures with these and label them 85 meters horizontally. Then it travels 45 meters at an angle of 30 degrees above the horizontal. Now what I'm being asked to find is the displacement of this roller coaster. Now let's recall that displacement is from where you started to where you finished, that magnitude, and the direction. So in this particular case, they're asking you to find this graphically, but I'm going to show you how to find it using trigonometry. To find it graphically, you need to put it on a piece of graph paper and measure and use a protractor. Let's do this using some math. If we have a right triangle, there are a lot of things that we can find and use with that using some properties of right triangles. In this particular case, by creating this side here, my displacement vector is now the hypotenuse of a right triangle. And I know that the hypotenuse, or side C squared is equal to A squared plus B squared. Okay? So if I know sides A and B, I'll be able to find the magnitude of my displacement vector, C. But sides A and B are unknown to me, and I'm going to use some trigonometry to find those sides. This side, 85, only goes to here, so this particular horizontal component is unknown to me. I'm going to call it X for now. This vertical component, which I'm going to call Y for now, is also unknown to me, but I can use the pieces of information that I have to find those sides. Now let's remember what our trigonometric ratios are. Sine of theta equals the opposite over the hypotenuse. Cosine of theta equals the adjacent over the hypotenuse. And tangent of theta equals the opposite over the adjacent. Now in our particular case here, we have a hypotenuse of 45. So the hypotenuse in this case is 45 meters. I also know that theta, the number of degrees in my angle, is equal to 30. So these pieces of information are known. So I can use this information with these trigonometric ratios to determine the sides that I need to know. Y is my opposite side, and you'll see that when we use this throughout the course, when we talk about the vertical side, we're going to be talking, or vertical component, we're going to be using the sine of this triangle. And when we're talking about our horizontal, we're going to be using cosine. And just like we've done when we rearranged other formulas, we can rearrange this formula to solve for the side that we want. If I multiply both sides by the hypotenuse over hypotenuse is 1, so I can cancel that, multiply by hypotenuse over here. So my opposite side then is equal to the hypotenuse times the sine of theta. So in this particular case, my hypotenuse is 45 times the sine of 30, which is my known angle. Excuse me. When I enter that into the calculator, make sure your calculator is set to degrees. When I enter this into the calculator, I get a value of 22.5 meters. So my vertical side is 22.5 meters. I can rearrange my cosine component in exactly the same way. And so I'm going to end up this time with 45, my hypotenuse, times the cosine of 30. And when I enter all of that into the calculator, I'm going to end up with an answer that rounds to 39 meters. So my x value here is 39 meters. Now my x side of my triangle right here is going to be 39 plus the original 85, okay, because that ended right here. But my vertical component here is going to be 22.5. So let's take a look at what it's going to do here. I'm going to redraw that triangle so it looks a little bit clearer to you. And here's my displacement. So 85 plus 39 is going to give me 124 meters for this side and 22.5 meters for my vertical. Now I can use Pythagorean theorem to solve. My hypotenuse, c squared, is equal to 124 squared plus 22.5 squared. That gives me a value of c squared is going to be equal to, let's put that in real quick, 124 squared plus 22.5 squared. So c squared is equal to 15,882.25. This is not our answer. Remember, we don't want c squared. We have to take the square root of both sides of that. So take my square root, and I get a value of 126 meters. This is the magnitude of that displacement. But we're not done because we also need direction. And so I'm going to choose an angle here, and I'm going to find the number of degrees in that angle so that I can then describe the direction that it's traveling. Okay, so I am now going to use my tangent function. The tangent of theta is equal to the opposite over the adjacent. Here's my opposite side still, here's my adjacent side. So the tangent, and this, remember, is not my original theta. This is one that I don't know. I'm trying to find the number of degrees. Is equal to 22.5 divided by 124. All right? So the tangent of theta is equal to 0.8145 and a bunch of other stuff. I'm going to need to take the inverse tangent. If you have this type of calculator, you're going to press the second key and then the tangent key, and this is going to say tangent with an exponent of -1. We're dividing by the tangent. And then I'm going to input my value, and I get a value of 10 degrees. So this is 10 degrees above the horizontal. So taken all together, the answer to my problem is 126 meters, 10 degrees above the horizontal. The next problem that we'll look at is found on page 89, and it's number 2. While following the directions on a treasure map, a pirate walks 45 meters north. Remember, we follow the same cardinal directions as a compass rose when we draw these. So 45 north, and then turns and walks 7.5 meters east. What single straight line displacement could the pirate have used to reach the treasure? So here's our displacement. We need to find both magnitude and direction. Now in this particular case, we don't have to go through all the fancy stuff that we did in the previous one in order to find our magnitude of displacement. We're ready to do Pythagorean theorem right away. C squared, my displacement vector, is equal to a squared plus b squared. C squared is equal to 45 squared plus 7.5 squared. Remember, I need to take the square root of my final answer, and I get that C is equal to 45.6. So I could round that to 46 meters. So we know he's going to have to walk 46 meters, but specifically in what direction? I'm going to find this angle here, and then I can describe the direction that he has to walk in terms of north. It's a little bit east of north, but let's find out how much east of north. Again, we remember our trigonometric ratios. Directly across from the angle is our opposite. The part that makes up the angle is the adjacent, and of course my displacement vector is the hypotenuse. Notice that I have the opposite and the adjacent, and tangent is equal to opposite over adjacent. I could use my calculated hypotenuse and use sine or cosine, but it's usually best to use what's given to you in the problem in case you made an error in your calculation. So what I'm going to do again is I'm going to use the inverse tangent function in order to find this. So I'm going to press second tangent. So the inverse or arctangent of this is equal to my opposite over my adjacent. Okay, so arctangent, second tangent, it'll give you parentheses, 7.5 divided by 45, close parentheses, and you should get an answer of 9.5 degrees. So the pirate could have walked 46 meters, 9.5 degrees east of north. Practice problem 1 on page 92 says, how fast must a truck travel to stay beneath an airplane that's moving 105 kilometers per hour at an angle of 25 degrees to the ground? Again, we draw a picture of what we know. Here's the ground, here's the airplane, and we know the airplane is traveling 105 kilometers per hour. We know the angle of the plane is 25 degrees. What we want to know is this bottom component vector, which will be the speed of the truck as it travels directly underneath the airplane. Notice here's our right triangle. So this side is our x side. So what trigonometric ratio will we need to use if we have the hypotenuse and an angle? If you guessed cosine, you're exactly correct. Remember, the cosine of an angle theta is equal to the adjacent over the hypotenuse. I can multiply the hypotenuse times both sides, and I can find the adjacent, which happens to be the side that I am trying to find. Let's insert our values, and it's cosine of 25 degrees. When I enter all of that in, I should get a value of 95 kilometers per hour.